All right, so tonight what I'm going to do is I'm going to talk to you about blood spatter. And by blood spatter, what I want to talk to you about is how to distinguish between drops of blood versus drips of blood. Drip sort of on the wall, sort of dripping down, oozing down, and then a pool of blood. So by blood splatter, we're really talking about any patterns that blood leaves behind at a crime scene. So it could be pools of blood, it could be drips of blood, it could be drops of blood, it could be spray, high velocity spray. We're gonna talk about all of those. So drops, drips, pools, all blood left behind at the crime scene. And you'll notice that this is a doodle notes. This is the way I actually do it in class. It's sort of fun because it's sort of fun to draw these patterns of blood drops that develop. So real quick review over here in the upper right. Remember the top of the blood. I'm sorry. I'm blind. The top of the blood, remember, was the plasma. Remember there was a layer in the middle. That was our platelets and our white blood cells. And the bottom was the red blood cells or the erythrocytes down at the bottom. So when I'm talking about this, sorry, that wasn't even on the screen. When I'm talking about this test tube, that's taking a blood sample and spinning it in a centrifuge, and the components of blood separate out by density. And so we get the most dense down at the bottom. Those are the red blood cells or the erythrocytes. We get the white blood cells or the platelets in the center, and we get the plasma up on top. Okay, and that's just space up there, the one that I initially labeled. Sorry about that. All right, and then we had also talked about presumptive versus confirmatory tests. And when I left off, I had given you notes that I wasn't actually walking you through. And they were just notes about all of the other different body fluids like saliva and semen, and the confirmatory or the presumptive test for those at the crime scene to determine what fluid of the body, urine, all sorts of things, what is it, and what was the test we would do at the crime scene. So that was the last note sheet. And I think if I remember correctly, I just had you copy it over. And so for blood, we actually have presumptive and confirmatory tests. And these were given to you in our note packet. The Kastle-Meyer is one of them. The Kastle-Meyer is one of those presumptive tests done right at the crime scene. Luminol, this is the one that with a black light, it turns into a blue glowing blood, but remember it had a lot of false positives like horseradish and bleach and stuff like that could also be positive on that test. A confirmatory test is the Takayama. The RSID test and the Diekman test. And when we talked about these in your notes, there was actually a test where in the lab it reacts. These tests take a reaction with the hemoglobin in blood, and that's actually what confirms in the lab that it is blood. So these would be done at the crime scene, and these would be done in the lab. So just quick review on those tests. So those are something that you should definitely know. Now there's two parts to the blood spatter. We're going to be done up at the top here in just a sec. The first one is pattern analysis. So the first sort of step to blood spatter identification is pattern analysis. So we'll talk about different patterns that result when blood is deposited at the crime scene. And then the next thing that we sort of do is we do some reconstruction. So that's sort of how we're going to work through this note packet, or this note sheet rather, is look at the pattern first, figure out the pattern of the blood, and then sort of reconstruct the crime scene. So the first thing I want you to do is I want you to determine how you can figure out the angle of impact for the blood. So if you see this blood drop right here, you can notice that it has a tail. Okay, I want you to sort of look at the blood drop without the tail. So I want you to take a look at the drop without the tail, and we're going to measure it. Okay, now first thing I want you to know is that the force has to be coming from this direction. How do I know that? Because of the tail. Okay, because of this tail, that means the blood actually spattered that direction to leave that tail over there. So that's how we know this direction of travel. We know that the force came this way and that the blood sort of spurted out that direction. All right, and that's what gives us the tail and maybe a few little splatters along the back end of that tail. And if we measure this little drop of blood, we're going to get, we're going to get, it looks like if I took off the tail, because remember, I don't want to measure the tail. That's going to throw off all my measurements. I'm going to get 3.8 centimeters this direction. And this direction, I'm going to get 1.7 centimeters. Okay, so if I went ahead and measured that, guess what I can do? I can actually figure out the angle of impact. So I can figure out the angle of force, or the angle of impact that deposited this blood droplet. And I can do this with a little trigonometry. I can figure out the angle of impact by taking the inverse sine of the width of the drop divided by the length of the drop. So that's actually what I'd like to do with you. I'd like to take the angle of impact is inverse sine, and then I'm going to take those two measurements. The width of the drop, what did I get? I got 1.7 centimeters in that width divided by my length of my drop, which was 3.8 centimeters. Close up my parentheses. And then I'm just going to solve this. I don't know if you can see my calculator, but hopefully you can. All right. So I'm just going to go ahead and I'm just going to check quick. I am in degrees. So I need to be in my degrees for this one. And I'm going to take the inverse sine. So second sine, 1.7 divided by 3.8. And I get the number 26.6 degrees. So the angle of impact is 26.6 degrees. All right, so I can figure out the angle of impact. What does that mean? Well, it means that there was a 26.6 degree angle of impact. So if this is the ground here, this would be where the blood drop would go. Okay, the angle of impact would be 26.6. We'll talk about reconstruction in just a little bit. Okay, so if we called this, say, the point of origin, this would be the blood droplet on the ground. Looks like a little mouse. Okay. All right, and this, I'm actually going to do an example with you on figuring out how to determine this point of convergence here and the blood drops that happen. All that I really need you to know for this one is that this is a form of cast-off. Now, cast-off is blood flying off a weapon. Sounds nice, right? So blood flying off of a weapon. So if somebody took a knife and they were hurting somebody with a knife, this may be one swing of the knife here. This would be another swing of the knife here. And this would be a third swing. Now, the cool thing is that you see this number 1, this number 2, and then I could put a number 3 down here. This actually is the first swing. Now, I told you it was the first swing, but how would you know that? Well, there would be the most blood on this knife if it was the first swing, right? It would be really wet at this point right here. So there would actually be 4 drops of blood on that first swing. The second swing, there's 3 drops of blood on that second swing. And then the third swing, let's say there's 1 drop, I added it, of blood. And that would be the third swing. you guys are going to miss out on my very favorite lab, where I actually give you a plastic knife and some blood, and we just spray it all over the classroom, and we just cover the classroom with paper. And it's really much better when you actually see the blood flying off of the knife, and you can really see this cast off pattern that happens, and you can really do some reconstruction of the crime with that cast off pattern. So we would have done all of this reconstruction for the crime scene. We would determine the point of the angle of impact, the point of convergence over here, which I'll show you in just a minute, and then all of the different reconstructions. So let's go ahead and just label this last part, the area or the point of convergence. Okay, the area of convergence. All right, and then this next part over here, this is really, well, if we have these angle of impact, which we had over here, right? This, you're seeing this term again, the angle of impact, angle of impact. I just want to show you some examples of angle of impact so you can sort of see it. If we have, say, a 90-degree impact, we would have a circular blood droplet, okay? So if it's a 90-degree angle and the blood drops directly down, so here's my finger, here's the blood dropping directly down, notice the pattern that's resulting right down here. It's a perfectly circular blood drop right here. Now, what you're seeing on these very outside, these are actually called satellites. And they're these little protrusions that makes it look like, actually it looks like coronavirus, doesn't it? It's just a blood drop, no coronavirus here. That's why we're all home. But this sort of does look like coronavirus. And what it has are these little satellites. And the drop is the satellite. This part right here, this sort of like the neck of the satellite is called the spine. And this actually happens, this sort of pattern happens on a soft surface. So something like carpet, you'd get these sort of sprays outwards. When the blood dropped from a 90-degree angle, it would give you a circular drop, but it would spray outwards in this little pattern, these little satellites with a spine and then a little blop on the end of it. Again, soft surface. A hard surface, what would it look like? Well, if it came from a 90-degree angle, it would actually look perfectly circular. And again, this lab that you're missing, I would have you do all of this right in the lab. So on a hard surface, notice the satellites are missing in this case. It's just a perfectly circular drop. All right, without those satellites. Now, just to contrast this, we had an angle of 26.6. So this drop right over here would actually be at an angle of about 26.6. That would be this one right here. All right. And then I drew you a 40-degree angle, although it did get cut off a little bit. This would be like a 40-degree angle. So what I need you to understand is that the smaller the angle, the more spread out the blood drop would be. Okay, so as we sort of went up in our angles, they would get more and more circular as we went upwards, okay? So that it would be more spread out here as the angle is smaller, and then as this angle goes up towards 90 at that circular droplet, it would get more and more circular as it went up. And I don't know if my drawing is doing a good job, but hopefully you can see that it's more spread out here, down here at the lower angles, and definitely more circular up here towards 90 degrees. All right, so that's that relationship between angle and impact and the length and width of the blood droplet. So if we thought about the length of the width of the blood droplet and we thought about 90, well, let's go ahead and pop that into our equation here. If we have the sine -1 of a perfect circle, like our 90 degrees, well, then that would be, let's just take our data, 1.7 centimeters divided by 1.7 centimeters. We could go ahead and I could prove this to you. The inverse sine of, of 1 is 90 degrees, and there it is, okay? So just as a just another way to say it. That if we have a perfect circle, that would mean that the length and the width of that droplet are the same, which would be an inverse sine of 1, which is an angle of impact of 90. So that's how we know that a perfect droplet, a perfectly circular droplet, would happen at that 90 degrees. I feel like I'm saying the same thing over and over again. So hopefully you've got that. That angle of impact. And like I said, I'll do another little activity with you in just a minute where I show you how to measure this. Okay, real quick, let's go ahead and do this down here. I wanted to get through this note packet fairly fast. So we have 3 types of blood stain patterns. We have passive, projected, and transfer. And as you can imagine, they are exactly as they sound. Passive are patterns created by gravity. All right, so they're circular drops, a series of drops usually, because somebody's probably bleeding. And this is something that's probably happened in your house. It's funny, I actually wiped blood off of my wall today. Like seriously wiped blood off my wall. My youngest son gets bloody noses fairly easily, especially when it's cold and dry. And he got a bloody nose and somehow the blood got on the wall, which I'm not exactly sure how. But the passive drop would be the blood that drips down. And remember, it creates, if it's dripping down, it's creating a circular drop. All right. So, remember, we can figure out the width and the length and figure out the angle of that drop. But most of the time for the passive, they're at a 90-degree angle. So they're circular drops. So because they're passive, they're usually circular or very, very close to circular, assuming the person isn't moving at a fast pace and making it sort of slightly projected. But they should be pretty close to circular. Projected is really held for when a force is applied to the source of blood. All right, and what we get is we get a few different things. We can get cast off, like down here, where we get blood released from a moving object. So cast off would be blood released from a moving object, like a knife, like a hammer, whatever weapon could be used that makes somebody bleed, and then the weapon has blood on it, and then when the weapon is used again, the blood is actually thrown off it or released off of it. Another one, I actually was talking to my kids about this one, an arterial spurt. This is one that'll be scary. All right, so cast off would just be blood flying off of a weapon. Arterial spurt is when blood is exiting from an artery. And this blood would be bright red. And it would be, like I said, it would be spurting. So if you decide to go into crime scene investigation and you went to a crime scene where there was an arterial spurt, you would know it. Probably if you came after a while, the blood wouldn't be so bright red as when it came out, but there would be evidence of large amounts of blood loss. An arterial spurt is called a spurt because it is actually coming out with pressure. So it's coming out of an artery which still has pressure from the heart. So as the heart beats, it actually squirts blood with in time with the heartbeat, and that's how it's coming out of the body. So it's really leaving a large amount of blood at the crime scene. And then the last one is impact spatter. And for impact spatter, this is when the blood is created by a force. Now, this could be anything from a punch to a gunshot. Not gunshot, gunshot. And if we're talking about a high velocity, something like a gunshot, this would be very high velocity blood spatter. and it would be very, very small, like speckles of blood all over the place. So it would be high velocity. When we do this in the lab, we actually use a toothbrush and we put blood on a toothbrush, and then we use the toothbrush, like the bristles of the toothbrush, and we sort of peel them back, and it sprays outwards from the toothbrush, and it gives this real fine, almost like a mist of blood. This is different from a punch, which would definitely be like sort of a squirt of blood out that could fall onto a wall possibly and then drip down. It could come at an angle and sort of spray outwards and give it a little tail. So lots of different patterns from a punch. But what I want you to know is that there's larger drops for the lower velocity. So a low velocity impact spatter would have larger drops, and a high velocity impact spatter would have really, really small drops. So gunshot would almost be like sprays of blood, whereas a punch or a knife wound, something getting hit by a hammer or something heavy, a lower velocity though, an axe, would have larger blood drops. That would be at that crime scene. So that's how you would have some idea of what type of weapon caused that impact spatter. All right, and then the last one is transfer, and this is a pattern that results when a bloody object touches a surface. So this could be like a bloody handprint, it could be a print, it could be a wipe, or it could be a swipe. So a print could be either foot or hand, a foot or a handprint, nose print, I guess. A wipe is where there's an object that wipes through the blood. So blood is there, and then an object sort of smears it around. And then a swipe would be like if the hand was bloody and it touches a wall. So there's a slight difference. I don't know if you picked up on that difference here. For the swipe, it would be if your hand is actually bleeding and it swipes, versus if it's a wipe, that the blood is sort of like left there on the surface, and then something not bloody moves the blood. Okay, so they're slightly different. The swipe is the bloody object smearing the blood, and the wipe is a brand new object that's not bloody, smearing blood that's already been placed there. So I hope that makes sense. That's a transfer pattern, or a pattern that touches a blank surface, and also evidence at a crime scene. So hopefully that all makes sense. I'm going to sign off for a minute and come back and do one more thing with you. But I hope that was helpful. Thanks. Bye.